Hello students, today let's try to understand heap sort. So I know many of you struggle to understand and visualize heap sort. So here I am to clear all your concepts. So let's #visualize. DSA. So from the empathy stage, I know that students struggle with heap sort due to lack of fundamental about heap. So let's jump into the core of heap before its application. So what is heap? A heap is a specialized tree-based data structure which satisfies the following properties: 1. Almost complete or complete binary tree. 2. Parental dominance, that is min heap and max heap. So let's have a look into complete or almost complete tree. In a complete binary tree, all the levels of a tree are filled entirely except the last level. In the last level, nodes might or might not be filled fully. Also, let's note that all the nodes should be filled from the left. Parental dominance. In a minute heap, the key present at the root node must be less than or equal to among the keys present at all of its children. In a max heap, the key present at the root node must be greater than or equal to among the keys present at all of its children. For more understanding about heap data structure and its representation, have a look at the documentation attached in our Android application. Okay. Before getting into heap sort, here is the real-world application of heap and heap sort. Heap sorting can be applied to a SIM card store where there are many customers in line. The customers who have to pay bills can be dealt with first because their work will take less time. This method will save time for many customers in line and avoid unnecessary waiting. I am facing a serious issue with my SIM card.
I have to pay bill.
I have to buy a new SIM.
I am here to pay bill.
Now coming to the construction of heap, which specifically is termed as heapify. As we saw before, heap data structure is of two types, minute heap and max heap. In this lecture we will see the construction of max heap. There are two ways to construct a heap: top-down approach and bottom-up approach. Let us consider the following array elements and try to construct a max heap for these elements using bottom-up approach. Very first step is to construct a binary tree for the given elements. Let us start the comparison of elements starting with the last non-parental node, or to make it simple, start with the n/2th node, where n is the number of elements in the given array. Note that the array index starts from 1, not 0. Here the value of n is 7. So 7/2, which is 3. Let this be some variable k. Start from the third element. Compare the third element with its children. Parallelly in the array, the index of the child node of any element present at index I is given by left child at the index 2i, and the right child is present at the index 2i plus 1. Compare the children nodes with the parent. If the value of children nodes is less than the parent node, proceed to next iteration. Else, select the greater node among the children. Interchange it with the parent node. Proceed to next iteration. Decrement the value of k. Now k becomes equal to 2. Compare the second element with its children. Repeat the steps. Find the greater among the children, and interchange it with parent node. Proceeding to the next iteration, the value of k becomes 1, which is the root node. Compare the root node with its children. If the children nodes have greater value, interchange. Here you have to be careful, because once you interchange, you need to compare the node with its new children nodes. Again, follow the same procedure. Compare and interchange. Hence, we obtain the final heap for the given array in this binary tree. Or to be precise, the max heap. All the parent nodes have greater value when compared to its child node. Okay, wait. Brainstorm time. You are given an array of elements and you need to sort the given elements using the concept of heap. Please pause your video and come up with an approach. I hope you found some approach. We will now deep dive into heap sort. Heap sort is a comparison-based sorting technique based on heap data structure. 1. Heap sort is an in-place algorithm. 2. Its typical implementation is not stable, but can be made stable. 3. Typically 2 to 3 times slower than well-implemented quicksort. The reason for slowness is a lack of locality of reference. Let's try to visualize heap sort using an example. You are given with an unsorted array. Your aim is to sort the array using heap sort technique. Example, 12 6 10 5 1 9 3. Working of heap sort. Since the tree satisfies max heap property, then the largest item is stored at the root node. Swap. Remove the root element and put at the end of the array. Put the last item of a tree at the vacant place. Remove. Reduce the size of the heap by 1. Heapify. Heapify the tree again so that we have the highest element at root. The process is repeated until all the items of the list are sorted. Considering this example, after heapifying the given array, we obtain the following tree. Swap the first and last node of the heap. Now the element 12 is in its correct position. Remove the element 12 from the heap. After removing the element 12 and heapifying the array, we obtain the following tree. Swap the first and last node of the heap. Now the element 10 is in its correct position. Remove the element 10 from the heap. After removing the element 10 and heapifying the array, we obtain the following tree. Swap the first and last node of the heap. Now the element 9 is in its correct position. Remove the element 9 from the heap. After removing the element 9 and heapifying the array, we obtain the following tree. Swap the first and last node of the heap. Now the element 6 is in its correct position. Remove the element 6 from the heap. After removing the element 6 and heapifying the array, we obtain the following tree. Swap the first and last node of the heap. Now the element 5 is in its correct position. Remove the element 5 from the heap. Now there is only one node left in the heap. We need not heapify it. Thus we sorted the given array of elements using the heap data structure. Heap sort has n log n time complexities for all the cases, best case, average case, and worst case. Also, since the build max heap and heap sort steps are executed one after another, the algorithmic complexity is not multiplied and it remains in the order of n log n. By now, I hope you guys have a clear visualization and understanding of heap data structure, and also the algorithm of sorting the given array elements using heaps. Thank you.